Hello friends, today I am going to say few words about sampling in statistics. So before we start, let us start with the definition of statistics. Statistics is the fact or data of a numerical kind assembled, classified and tabulated so as to present significant information about a given subject. Therefore, statistics is the science of assembling, classifying and tabulating such facts or data. Major classifications: descriptive statistics, inferential statistics. Regarding descriptive statistics, we can say that descriptive statistics consists of all methods or techniques for collecting, organizing and summarizing the collected information or data. And inferential statistics consists of all methods for the generalization or conclusion or decision about the population based on sample or descriptive statistics. Two most important concepts of statistics is population and sample, where population consists of all individuals or items or objects under the statistical study taken by the researcher. Sample is just a part of the whole objects or items or population from which the informations are collected or obtained. Methods of data collection. So we can classify the methods of data collection from three angles: census method, sampling method, experimentation. According to census method, information of data are collected from the entire population under study. In our nation, central government conducts census survey every after 10 years. Hence, conducting a census not only time consuming but also it needs huge money, labor, etc. And sometimes it becomes impractical or impossible also, especially for the individual researcher. The two other methods of obtaining data or information collection are sampling and experimentation. So sampling methods, regarding sampling methods, sampling we know is the method for obtaining sample or data or information related to the study from the population. This sample will be used for drawing conclusion or decision or generalization about the entire population related to the object or study. Hence, this sample should be representative sample. Broadly, sampling methods can be classified into two groups. One is probability sampling and the other is non-probability sampling. So probability sampling is when each and every member of the target population has a known chance of being selected in the sample, then it is known as probability sampling. On the other hand, when the particular unit of the population under study is selected deliberately by the researcher for the sample with respect to some convenience or purpose or judgment, then it is known as non-probability sampling method. The probability samplings are four kinds, more or less five: simple random sampling, then systematic random sampling, stratified sampling, cluster sampling, and the combination of all that is multi-stage sampling. Similarly, non-probability sampling can be viewed from convenience sampling, from snowball sampling, the purposive or judgmental sampling, and quota sampling. So these are the four classifications under non-probability sampling, and these are the five classifications under probability sampling. So simple random sampling means, according to this method of sampling, each possible elements or objects of a given size under study is an equal chance or probability of selection as an element of the sample. Similarly, systematic random sampling, in this method systematically a number is generated first, then sample are selected from that selected number of the element from the population under study. For example, suppose 10 volunteers will be selected for conducting a cultural program from 600 population standing in a line. According to this technique, we first divide the population by sample size, that is 10, then randomly select any number. After the division, we will get 60, then randomly select any number from 1 to 60. So randomly select any number from 1 to 60. Say suppose this is 25. This will be the first element of our sample. The next successive elements will be derived by taking 25 plus 60th person in the queue, that is 85th person. Next will be 85 plus 60th, that is 45th person, and in this way we have to collect 10 samples. So one system is there and randomness is there. That is why it is systematic random sampling. The next is stratified sampling. According to this sampling technique, first the population or all possible element under study is divided into subpopulation with respect to some criteria, maybe income, gender, caste, religion, region, etc. In literature, these groups are known as strata. In the next step, elements or objects are selected randomly from each strata to form the sample. Selection of elements from each strata may be equal percentage or not equal in size depending on the nature or need of the study. Now examples of stratified sampling. Suppose in a school, NSS team members will be selected from the students of class 8 and 10 only, and comprising total 600 students. The members or team, NSS team should consist of all kinds of caste students, that means general students, SC, OBC, ST, all caste students should be there. Hence, according to the this technique, total 600 students will be classified with respect to their castes. Hence, each caste represents a strata. So total student strength is equals to by taking a class 8 and 10, suppose 600, where the general 60% students is 360, the SC is 20%, suppose 120, OBC is 15%, that is 90, total 90, and ST is 5%, that is 30. So these are the 4 strata. Okay. Now if 10% students are selected randomly from each strata, the total sample size will be 10%, that means 36, 12, 9, 3, that is equals to 50. So the NSS team will consist of 50 students from class 8 and 10 according to this sampling technique. Now cluster sampling. According to this method, the total population under study is divided into few clusters or groups or blocks. Then few groups, clusters, blocks will be selected randomly. The researcher needs to collect information from all units of that group, block, cluster obtained from random sample, or each element of that group will be the elements of the sample. Suppose you want to investigate the effectiveness of a government scheme in a particular block. Also suppose that the block consists of 20 gram panchayats. Hence, the researcher first selects randomly 5% of the gram panchayats, that is 5. 5% means how much? 5% means, okay, that is not 25%. 25% of the gram panchayat, that is 5. Then the researcher collects information or required data from each households of these 5 gram panchayats. So this is known as cluster sampling. So after randomly selects the number of gram panchayats, it may be any kind, it may be 5 or 2 or even sometimes 1, but the researcher needs to collect information from each and every household of that GP or of that GPs. So this is known as cluster sampling. So this is population. So that means it is divided into few blocks or GPs. Okay. Now after taking suppose 1 or 2 GPs randomly selecting, now the researcher needs to collect information from each and every households of that GP. Suppose this one and this one, and according to this example through diagrammatic, we can explain in this way. Now multistage sampling, when the researcher combines one or more of probability sampling, that is simple random sampling, systematic random sampling, stratified sampling, cluster sampling, etc., then it is known as multistage sampling. Now coming to non-probability sampling. So first one is convenience sampling. According to this method, the elements or members of the sample are selected on the basis of their convenient accessibility. So on the basis of their convenient accessibility, only those elements, that is households, individuals or other objects related to the study, are selected which are easily accessible to the researcher. Okay, so sometimes the research regarding the collection of primary data collection in hill areas, it is not possible for the researcher to go in remote areas, so because of the access problem. Hence, with respect to the convenience of the researcher collects the information who are adjacent to a particular place or something like this. So convenience sampling, there is no question of probability, that is why it is non-probability sampling. Now snowball sampling, according to this method, first one element or individual or respondent is selected, then from that respondent another respondent or objects or elements related to the study are selected. This process go on until sufficient or a sizable sample is obtained. For example, for searching criminals related to a particular crime, police uses this type of sampling technique for getting culprits involved in that crime. The purposive or judgmental sampling, according to this sampling, the sample are collected according to the purpose of the study. For example, problems related to potato cultivation, researchers should ask questions to those farmers who are actively engaged in potato cultivation. Hence, if the researcher randomly selects farmers and asks questions those who are not engaged in potato cultivation, the information will not be suitable or the study will not provide good results. So here, with respect to some purpose, the researcher should collect information. Similarly, quota sampling is another non-probability sampling. According to quota sampling, the samples are selected according to some specific rules, characteristics that is required for the study. These specific characteristics, maybe government order or rules, serve as quota for the selection of the elements or members of the sample. These characteristics may be gender, may be income limit, may be residential area, may be educational level, marital status, etc. Experimental sampling design. So after census and sampling, another type of technique is experimental sampling design. When data or information are collected through experiments, it is known as experimental sampling. It can be classified from two groups. Generally in pure science, experimental sampling methods are used. One is observational studies, another is designed experiments. Excuse me. Observational studies, we can say in this way, when samples or data or information are collected just by observing the association of two variables. It is known as observational studies or sampling. For example, the 10,000 persons, suppose within the age of 50 to 70 years with comorbidity, that means having high BP and high sugar, blood sugar, are selected randomly and tested, among which 160 are infected with COVID positive cases. On the other hand, the same number of persons, that is 10,000, with the same age group 50 to 70 years without having the comorbidity, that means without having any blood sugar and tests, though this is rare cases, but still we are assuming that without having any comorbidity are tested, within which suppose 85 are found COVID positive. Hence we can draw that probability of COVID infection increases 88% with comorbidity for the given age group of people. Now, sample through designed experiments. In this case, the researcher applies some treatment and observe the result or compare the result with another sample or another group of the same size without giving the same kind of treatment. For example, again we are taking 10,000 persons with the age of 50 to 70 with comorbidity are selected and randomly and having first dose of vaccine, those who have already taken the first dose of vaccine, and tested, among which 70 cases are found positive. Suppose on the other hand, the same group of people but another group of people but with respect to same criteria, that means 10,000 persons within the age of 50 to 70 with comorbidity are selected randomly without having the first dose of vaccine, without having the first dose of vaccine, and then tested, among which 130 cases are found the COVID positive. Same number of persons with same age, with comorbidity, that means with blood sugar and high BP, selected randomly, but without having even the first dose of vaccine, and tested, among which if suppose 130 are found COVID positive. Hence, we can draw the conclusion that the first dose of vaccination or vaccine can reduce the probability of COVID infection by 88%. In this way, we can explain. Thank you.